Okay, so today I'm going to go over the review for test number 5. Alright, so it starts off with expanding the log using log properties. So the first one is log A times B. So when you have a multiplication, separates with an addition sign. So it'll be log A plus log B. Okay, number 2 is log the cube root of A divided by B. So another way to write the cube root of A, remember power of the root, so the power of A is 1. So this would be log A to the 1/3 power over B. And then a division separates with a minus, so it'll be log A to the 1/3 minus log B. And then the rule for the exponent is the exponent goes in front. So it's 1/2 log A, 1/3, sorry. 1/3 log A minus log B. Okay, and number 3. Okay, so number 3 is log the square root of AB, which is log, parentheses, AB to the 1/2 power. So the whole thing is under the radical. Radical is the square root symbol, so that's to the 1/2 power. So that is log A to the 1/2 power, B to the 1/2 power. So now we can separate them since it's multiplication with a plus. So it's log A to the 1/2 power plus log B to the 1/2 power. The rule for the exponent goes in the front. So it's 1/2 log A plus 1/2 log B. So that's one way to write it. You can factor out 1/2 because they both contain 1/2. So it would be 1/2 log A plus log B. Okay, so let's take a look at number 4. Okay, so number 4 is finding logs using change of base formula. So I have log base 8 of 64, which is log 64 divided by log 8. So you plug that in your calculator. Log base 8 of 64 is equal to 2. Next one, log base 3 of 8 is log 8 divided by log 3. That you can plug in your calculator. You get 1.892789261. Log base 2 of 12 is log 12 divided by log 2, which is 3.5849650. Okay, let's take a look at 7. Okay, 7, 8, 9, and 10 is to solve for x. So I have 7 to the x power is equal to 1 over 49. Okay, so I want to take the 49, move it up top, so I change the sign of its exponent, which its exponent is 1, so it moves up and becomes 7 to the x power equals 49 to the negative 1 power. So we want to get 49 a base of 7, so that's 7 squared. So that's 49 raised to the negative 1 power. So that's 7 to the x is equal to 7 to the negative 2, so x is equal to negative 2. You get the same base. The exponents are equal to each other. Okay, number 8. 2 to the x, 3x plus 1 is equal to 32. Okay, so I want to get 32 with a base of 2. So 32 base 2 would be 2 to the 5th. And on the left side would be 2 to the 3x plus 1, same base that the exponent is equal. 3x plus 1 is equal to 5. So I get 3x is equal to 4. X is equal to 4/3. Okay, and number 9, the log base 4 of x is equal to 3. So I want to put it in exponential form, so the base is 4. These two switch, so it's 4 to the 3rd power is equal to x. So x is equal to 64. And number 10, log base x of 625 is equal to 4. So base is x, so it's x, these two switch to the 4th power equals 625. To get rid of the exponent, you could either take the 4th root of both sides or multiply the exponent by its reciprocal, which is 1/4. Raise 625 to the 1/4 power, so that we get x is equal to 5. Okay, so let's take a look at number 15. Okay, so number 15 is the word problem. So here's my formula. A is equal to P times 1 plus R over N raised to the nth power. So A is the balance in an account. P is your principal, what you invest. R is your rate expressed as a decimal. Move the decimal 2 places to the left. N is the number of times it's compounded per year. And T is the number of years we're trying to figure out how much is in the account after a certain amount of time. All right, so we have Bill invests $2,500 at an annual interest rate of 8% compounded monthly for 10 years. What did his investment grow to? All right, so his investment is $2,500, so it's $2,500 times 1 plus. The rate is 8%, so it's 0.08. It's compounded monthly, that means there's 12 months in a year. Raised to the 12 times, and we're looking for how much is in the account after 10 years. Okay, so this you could just plug in the calculator all at one time. And after 10 years, he will have $5,549.10. Okay, so let's take a look at 16. Jill invests $12,000 at an annual interest rate of 7.5%, compounded quarterly. If untouched, what will her investment grow to in 5 years? Okay, so we have A equals, she invests $12,000 times 1 plus, the rate is 7.5%, so it's 0.075, over, it's compounded quarterly, which means 4 times, raised to the 4 times, and we want to know how much is in the account after 5 years. So just plug that in the calculator all at one time, and you get $17,399.38. Okay, so let's take a look at 17. Okay, so number 17 is using the properties of exponents to see which of these functions are equal to each other. So I want to rewrite these. So I have 2 to the x minus 2 to the second. 1/4, so this is f of x, equals. Another way to write 1/4 would be 4 to the negative 1. And then to write 4 to the negative 1 would be 2 to the negative 2. And that's times 2 to the x power. And that's g of x. And h of x, so I have 2 to the x minus 2. So this is 2 to the x times x to the negative 2 power. So it would be g and h are equal. Okay, so let's take a look at number 18. Okay, so we have f of x is equal to 9 to the x plus 12. G of x is equal to 3 to the 2x plus 4. And h of x is equal to 81 to the 3x power, times 3 to the x power. Okay, so 9 would be 3 to the second to the x, so that's 3 to the 2x, plus 12, nothing to do with 12 there. 3 to the 2x plus 4 would be 3 to the 2x times 3 to the 4th. And h would be 81 is 3 to the 4th power times 3 to the x. So these 3 to the 4ths are the same, but I have 3 to the 2x here and 3 to the x, so they are not equal, so none of them are equal. Okay, so let's take a look at 19 and 20. Okay, so I have the function g of x, and I want to know what is the transformation that maps f of x, which is log base 3 of x, here's my parent function, and what's the transformation that maps that to g of x, which is log base 3 of x minus 1 plus 2. All right, so I have a minus 1 to x, that means I'm moving it to the right 1 unit, and I'm adding 2 to the y, so it'd be up 2. And then it says, what is the domain, the vertical asymptote, and the x-intercept for g of x, and it says to sketch it. Okay, so let's sketch it here. So remember, my basic log function is, the asymptote is x equals 0. So I'm moving to the right 1 unit. That means my asymptote is going to move to the right 1 unit. So let's see here. Okay, so my asymptote is moving 1 unit to the right. So here's my asymptote. That's x equals 1. Okay, so you could put this in your calculator. You could graph it. Right, so I have when x is 2, y is 2, x is 4, y is 3, x is 10, my y is 4. So when I graph it, okay, so your graph looks like this. So remember, it gets closer and closer to that asymptote. X is equal to 1, but it doesn't touch it. Okay, so there was a couple things that we needed to find the domain. So it doesn't go past 1. So my domain is from 1 to infinity. My asymptote, my vertical asymptote, we already said is x is equal to 1. And my x-intercept, okay, so your x-intercept is when your y value is equal to 0. So I'm just going to move everything up. Okay, so we want to find the x-intercept here. So I'm just going to move everything up. Okay, so your x-intercept is when your y value is equal to 0. So we have 0 is equal to log base 3 of x minus 1 plus 2. So minus 2, we get negative 2 equals log base 3 of x minus 1. So I have 3 to the, my base is 3. So it's 3 to the negative 2 power equals x minus 1. 3 to the negative 2 power is 1/9 equals x minus 1. Add 1 to both sides, we get 10/9. So my x-intercept would be 10/9, comma 0. Okay, so let's take a look at the last one, number 20. Okay, so number 20 says the population of a town increases according to the model P of t equals 1500 times e raised to the 0.0293 t. Now this is the point. T is the time in years from t equals 0 corresponds to 2000. So at time is 0, that means it's 2000. Find the population in 2005 and in the year 2010. All right, so I want to start off with P of 5, right, because t equals 0 is 2000, so t equals 5 would be 2005. So it's basically the number of years since 2000. So I have 1500 times e raised to the 0.0293 times 5. Plug that in your calculator, and you get 1,736.66, but you can't have 0.66 of people, so it's 1,736 people. Okay, now we want to do P of 10, because I want the year 2010. That's 10 years since 2000, so it's 1,500 times e raised to the 0.0293 to the 10 power. So just plug that in your calculator, and you get 2010.66, which is 2010 people. Okay, so the next thing is you want to graph the function from 2000 to 2015. So I'm just going to move this up here. All right, so I want to graph this. So I'm going to label my axes. This is going to be my time. This is years. I'm going to do years since 2000, because I'm going to go 2, 4, 6. So that's 2002, 2004, 2006, 8, 10, 12, 14, 16. And I'm going to go, well, I know at the year, in the year 2005, it was 1,700 people, so I'm going to go by 500. So it'll be 500, 1,000, 1,500, 2,000, 2,500, and we'll do 3,000. And this is P of T, this is population. Okay, so you can plug it in your calculator. Let's get a table of values so I can plot these points. All right, so we have 0 is 1,500. 2 is 1,590.5. 3 is, not 3, we're going to do 4. 4 is 1,686.5. 6 is 1,788.3. 8 is 1,896.2. 10 is 2,010.7. 12 is 2,132. 14 is 2,260.7, and then I want 15, which is 2,327.9. All right, so plot the points. So make sure you get 15 in there, which is 23. So it looks like this. Okay, you have to make sure you stop at the 15. Don't put an hour at the end because I'm only graphing from 2000 to 2015. So your graph should look a little bit neater than mine. Okay, so then it says, in what year will the population reach 2,500? So I want to know this here. When is my population going to reach 2,500 here? So graph y is equal to 2,500, and then we'll find this point of intersection here. So graph that on your calculator. Do second so graph both on your calculator. Do second intersect the number 5, and this comes out to be 17.43, comma 2,500. Okay, so remember x is the number of years, so it's 2,000 plus 17.43, which is going to be the year 2017.43. So it's sometime during the year. So sometime during the year 2017. Okay, so that's it, and have a good night.
This looks so good.
Yeah.
Now should